Hello, welcome to this video. We're going to be doing some problems in the topic of forces. So we're going to start off with this problem right here, which says a 60 Newton plant, is hanging from two strings attached to the ceiling. The string on the left forms a 45-degree angle with the ceiling, and the string on the right forms a 55-degree angle. Therefore, we're going to be drawing our plants right here. So it says that we have an angle right here of 45 degrees and an angle over here of 50 degrees. 55, sorry. 55 degrees. And we're trying to determine the tension in both strings. Give me 1 second. All right, we're trying to find the tension in both strings. Therefore, here's our little plant right here. And we're going to make the very first step is going to be our free body diagram. Therefore, we have a tension over here, a tension over here, and we also have some weight. So I'm going to write down FT1, FT2, and weight right here. From there, I know that since I have a 45-degree angle over here, it's going to be the same as this angle right down here. And same thing with the 55-degree angle. Therefore, I can go on to my next step, which is a table. And in the table here, we have the magnitude of my forces. So weight, tension 1, tension 2. Okay, then we have our angle. For our angle, for weight, we already know it's 270 degrees. For tension 1, it's directly 55 degrees. And for tension 2, it is going to be 180 degrees minus the 45 degrees. 180 minus 45 degrees, which gives me 135 degrees. From there, I'm going to get my x and my y components. Remember, my x and y components, I'm going to do the magnitude times cosine of my angle for the x and magnitude times sine of the angle for y. Okay? Therefore, in this case, I'm going to get 0. In this case, I'm going to get -1 times my force of weight, which is minus force of weight. Then we have 55. So I'm going to do cosine of 55, which is 0.574 times my force of tension 1. Then I'm going to do sine of 55, which is 0.819 times force of tension 1. Okay, and from there, I'm going to do cosine of 135, which is negative 0.707 FT2. And over here we have sine of 135, which is going to be same thing but positive 0.707 FT2. From there, I'm going to do step 3, which is going to be adding up both of my equations here. So I have 0.574 FT1 minus 0.707 FT2 equals mass times acceleration. This is the sum of my forces in x, some forces in x, and some forces in y. I'm going to do minus weight plus 0.819 FT1 plus 0.707 FT2. Now we know that the plant is not going to be moving. Therefore, my acceleration, both in x and in y, are going to be 0. Therefore, here 0, here is 0. And from there, I am going to be substituting this value right here, which is the 60 newtons, in my weight. So right over here, negative 60. And now I have two equations with two variables, therefore I can solve my system of equations by isolating for one of the variables and substituting in the other one. Therefore, I have that ft1 is going to be equal to 0.707 ft2 divided by 0.574. And this right here is going to be in my equation for the forces in y. So -60 plus 0.819, and I'm going to substitute here. 0.707 ft2 divided by 0.574 plus 0.707 ft2. And this is equal to 0. Now that I have that equation, I can isolate for ft2. So I can solve actually for ft2. Therefore, 0.819 times 0.707 divided by 0.574. I'm gonna have 1.009 ft2 plus 0.707 ft2 equals 60. So I can add those two together, 0.707. And I can get that my ft2 is equal this is going to be around 35. Rounded. And my other tension is if I substitute this 35 times 0.707 divided. I'm substituting into right here, okay? Divided by 0.574. That is 43. Okay. Newtons right here. So now I already have my two tensions. All right, the next problem says a car is traveling at a constant velocity of 25 meters per second on a road. The car experiences a friction force of 500 newtons, sorry. What is the magnitude of the engine's force to keep the car moving at this constant velocity? Therefore, step number 1, I'm going to be drawing my free body diagram. In this case, I have a friction force. It really doesn't matter if the car is moving to the right or to the left, it's going to get me the same answer. I also have an applied force by the car itself, by the motor. I have a normal force that's coming from the ground and the weight. So this is my free body diagram. From there, step 2, I want to do the table right here. X and Y. And my direction and my magnitude. My magnitude of my weight, of my normal, my applied force, and my friction force. So from here, I'm just going to be adding the directions. So 270 degrees, 90 degrees, 0 degrees, and 180 degrees. Therefore, these two are going to have 0 on the y-axis. These two are going to have 0 on the x-axis. This you can do directly with your calculator by doing the cosine and sine correspondingly of each angle. And therefore, I'm going to get -1 in this case, times my weight, which is negative weight, and a positive normal force. And over here, I'm going to have a positive applied force and a negative friction force. From there, I'm going to get my equations, which is my step 3. And I have in the sum of my forces in X is going to be equal to my applied force minus my friction. And my sum of my forces in Y is going to be equal to my normal force minus my weight. These are both equal to mass times acceleration. Now let's ask, what is our acceleration on each axis? On the x-axis, we're moving at a constant velocity. Therefore, our acceleration is going to be 0. 0 right here. And on the y-axis, we're not really moving. Therefore, our acceleration is also 0. Okay? This means that my applied force is going to be equal to my friction force, and my normal force is going to be equal to my weight. Now, if I go back to the problem, it says that I have a friction force of 500 newtons. Therefore, if my applied force is the same as my friction force, then that means that the applied force has to be the same as my friction to be able to move at a constant velocity. All right, and last but not least, I have this problem that says a 50-kilogram crate slides down a 35-degree inclined plane. The crate experiences an acceleration of negative 2.5 meters per second squared due to friction. Calculate the normal force acting on the crate and the coefficient of kinetic friction between the crate and the surface. So I'm going to draw real quick my inclined plane here. And I have a crate right here. This angle is 35 degrees. And first step, I'm going to do my free body diagram. Therefore, I have a friction force going this way. I have a normal force. And I have a weight. In this case, it doesn't say that we have that somebody is pushing the crate or pulling it in any direction. Therefore, we don't have an applied force itself. Okay. Now we said that since we have a motion here that is both on the x and on the y-axis, it is much easier to switch the vectors to sort of flip them over. So I'm gonna have my friction force go completely this way. This would mean that now my movement is going this way. Okay, so keep that in mind for the rest of the steps. Okay, now this angle right here is going to be the same angle that we had over here because that's how much we moved when we rotated our axis. Okay, and therefore this is also 35. So step 2, we're going to do our table. And I'm going to put it right here. So in our table, we have an x and a y. We have our direction, and I'm going to write down the magnitudes of each one. Force of weight, force of friction, and the normal force. I'm going to pull this down. Okay. My weight, I'm going to make this a little bit bigger just for a sec. Okay. My force of weight is actually not going to be 270. It is going to be 270 minus this angle that we moved it already. Okay, therefore 270 degrees minus 35 is going to be 235. My friction is 0 degrees, and my normal force is going to be 90 degrees. Okay, therefore, if I put in my numbers, I am going to get 0 over here, 0 over here. I'm going to get, if I do sine of 90, I'm going to get a 1 times my normal force is just normal force, and same thing for the friction. If I do cosine of 0, I'm going to get 1 times my friction is friction. Okay? And from there, I'm going to do cosine and sine of 235. So cosine of 235 would get me a negative 0.574 times my force of weight. Remember to add that, okay? We're still multiplying times the magnitude, all right? Then I'm gonna do sine of 235. And I have a negative 0.819 force of weight. Let me just make sure. Okay. From there, I'm going to do my equations, which is step 3. In step 3, I'm going to do the sum of my forces in x, which is negative 0.574 force of weight, plus my friction force, equals mass times acceleration. And same thing for my forces in y. 0.819 force of weight, plus my normal force, equals mass times acceleration. Now, here's where the rotating of the vectors comes in, okay? So since our movement is now only on the x-axis, I only have an acceleration right here. On the y-axis, I don't have an acceleration. Therefore, this is automatically going to become 0, okay? This means that our normal force is going to be equal to negative 0.819, my force of weight. Now, the force of weight, we already know. I'm gonna bring it down just a bit. Well, I'm gonna write it over here. My force of weight is equal to the mass times gravity. The mass, we already said right up here that it is 50 kilograms. Therefore, 50 kilograms times 9.81 meters per second squared. This is equal to my force of weight, 9.81, which is going to be 490.5. Therefore, if I substitute right over here, then I'm gonna get that my normal force is equal to, this is 0. This is actually going to be positive since we passed it over. 401.719. Let's keep it at that. Okay. Let me just make sure that we're on the right track. Okay. From there, we already got our normal force, which is one of the things that the question was asking for. And the question was also asking for the coefficient of kinetic friction. Therefore, I'm gonna go to my friction is equal to my coefficient times my normal force. The normal force I already have. The friction I don't have just yet, but I can get it, okay? Because I'm gonna move this down for a bit. And this came over here. This was right here. This is actually newtons over here. Okay, so from here, I already know my weight, so I can isolate for friction. My mass is 50 kilograms. My acceleration is, if I look up here, I think it says negative 2.5 times negative 2.5 meters per second squared. That plus 0.574 times 490.5 newtons. That is going to equal our friction. Therefore, our friction is going to be equal to 50 times 2.5, negative 125 newtons, plus 0.574 times 490.5 is 280. No, sorry, 281. 281.547. This minus 125, that gets me 156.547 newtons. So I'm gonna substitute this into over here. 156.547 equals coefficient times 401.719. Therefore, this divided by 401.719. This is going to get me a friction coefficient of 0.389. And that is how we solve this problem.